So we have 2 more weeks school left, right?
Bless.
And probably nobody's gonna be here last Friday.
Need more
We
time.
anything in the last like because we have like finals.
Block period.
Yeah, right.
We are
Oh.
doing block period.
Oh, I'm not showing up to school.
You're gonna have multiple choice tests.
Oh, one of those again for
What's that one?
the multiple choice, like the practice multiple choice you gave us last year.
Over the break.
Yay.
Over the break or just for funsies?
For the final exam.
Oh,
For the
During
midterm.
block.
oh, we're gonna do an actual MCQ.
Wait, that's our exam?
We didn't do midterm.
What are you talking about, Mr. Yi?
All right, so let's talk about DI method, and you can go back to talk about your homework.
Well, half the third period is full.
What's your third period?
Here,
Do you have a block schedule already?
but just whenever it is. I might add you. I think I had you for a blog 2 times earlier this year. That'd be funny if that happened again. I had you for like 4 hours a day.
That would kind of suck.
You played basketball like the whole day.
Did we? The book classes were off. The third.
Oh yeah, that's true.
Third. Yeah.
You should have seen my highlight reel yesterday.
I should have played yesterday. I should have brought my homework out there. Or the test, and that's our plan.
All right. So what's integration by parts? Integration by parts. My bad.
My bad.
Okay. So the idea is how are we gonna take the integrate of certain functions, and there's no proper tool for it. So for example, integration of natural log of x dx. And so that means which function derivative is going to result as natural log of x by itself. So it's probably easy to come up with it, but it's a little bit challenging. So can you think of any function, take a derivative, it's going to give you natural log of x? If you can do that, then that's the integration of it, right?
Like 1 to the x.
Huh?
It's like 1 to the x.
No. Derivative of natural log of x is 1 over x. Not an integral of natural log of x.
Yeah. No, I said 1 to the x.
1 to the x?
Yeah.
No. Okay, so what do you need to know? There was L, I, A, T, E. L stand for log. I stand for inverse trig. A stand for algebra. T stand for trig. E stand for exponential, especially e to the x. So in this order, that just start with L, like integration natural log. There's no way for me to take integration of natural log of x. And also there's no way for you to take integration of arc sine of x. Algebra is okay to by itself, right? Trig is okay to be by itself because we know all the trig rules. So especially those two individually by itself, it's not possible for you to take integrate. Inverse 10, arc 10 of x, it's hard to take integration of that. So there's got to be a rule to help you to integrate that. So this is where integration by parts come in. And we're going to only talk about the easy part of integration by parts. We're not going to talk about harder part. Harder part is going to be, there's some question a little bit harder than the other one. But for integration by parts in AP exam, it can also be used, take care by DI method. which is I will prefer to do that method. The reason why I teach that method is there's two people out there that who's very where I get my information from. One's Professor Liner, and he's really good, but he only talk about integration by parts. And there's another person I really like is the Blue Pen and Red Pen. I think Daniel used him a lot. Blue Pen and Red Pen is really good. So he talked about DI method. And so when I used to teach the first year, I taught integration by parts. And I realized that DI method is significantly easier than integration by parts. But I'm still going to talk about the formula of it because sometimes on AP exam, you do get a formula rather than anything. So the formula is going to be integration of u dv is equal to uv minus integration of v du. So this is the integration by part. And the way you want u equal to, it's always the priority of LIATE. So if a natural log occur first, then you're just going to set u equal to natural log of x. Okay, so the proof of natural log, I'm just going to write down for you. The proof of natural log is if I take a derivative, it's actually coming from product rule. So I'm just going to write down for you. I'm not really good at explaining this part, so I'm just going to write down for you, see if you can understand it good. So the proof of how you get this.
Is that an 8 or D?
Yeah, take a derivative respect of x of uv. So that is going to be u dv dx. This is the proof. So this is the proof. There was actually proof without words. And I was hoping some of you guys can figure out because I didn't understand what I mean by proof without words. The geometric proof is kind of interesting, but that's probably require a little bit higher understanding. But my teacher never proved to me, so I don't have to do anything with that. I just have to memorize this formula right here, which is what we're gonna do, but we're also gonna do DI. But in the AP exam, you need to know this formula because sometimes they can written this question with this formula in mind. So if I take a derivative of this, it's going to be a product rule, which is I can rewrite this as u v prime plus v u prime. Yeah. V. Yeah. So what at this point, it can actually integrate both sides. If you integrate both sides, you're going to get uv because you take a derivative of u and v, you should result with derivative of u and v. But if you take integration, it should go back to u and v. And then that's equal to u v prime dx plus v u prime dx, which is also known as integration of u dv plus v du. Now, remember, this is a product rule. This is a product rule from the back while ago last year, very beginning when we take a derivative. Now we use the product rule to find out there was an integration by parts. So what happened is I am gonna solve the udv. So I'm gonna solve this part. So integration of udv is equal to uv minus integration of v du. So that becomes a famous proof for integration by parts. Now let's go back and talk about what's integration of natural log of x. Dx, of course. Now, u is going to be priority. U is going to be what?
Natural log.
Mm-hmm. And what is du?
1 over
1 over x. Good. And what's dv?
dx.
Dx? What is v? X. Good. So then you remember this is equal to uv, right? So it'll be x ln of x. Does that make sense? Minus integration of v du. So it'll be 1 over x times x. This part is integrable. So that's going to be x ln of x minus x plus c. So that is a very well-known proof of proving how to take integral of natural log of x. If you don't believe it, you can take a derivative of this. Imagine that if I take a derivative of this, so that's a product rule, so it'll be x times 1 over x plus 1 times natural log of x minus 1. So that's 1 plus natural log of x minus 1. That's equal to natural log of x. You see, go back to natural log of x, which is what we know of, is x natural log of x minus x plus c. That's the integral of natural log of x. Good? Now, for me, I'd rather do DI method. I think I would be honest with you. This is the 3rd year I teach in Calc 2. And most of you guys are guinea pig for the first 3 years. I'm not going to get really master at teaching Calc 2 until the 5th year. At least there's a very well-known teacher. He's my good friend. And he always says, you know, you really need a 5 year to master the topic. And I didn't believe him. I taught pre-calc the first year. I thought I was the badass. I was like, I know how to teach pre-calc. But end up, at first year, I make so many mistakes. In the 2nd year, I make a lot of mistakes as well, but it's not as much the first year. In 3rd year, I start getting a little bit better. Like, I start turning around. But even my shitty year, I still do pretty good job. So you don't have to worry about whether you're going to pass AP exam or not. Because 87% of people pass the AP exam. Yeah, 60% have 5. So it's not a problem. But I will tell you there's some question I don't know how to answer you. And so it will start to get in the moment. Sometimes you're going to ask me a question. I'll be like, okay, I'm going to have to look it up or something in that.
Well, here's one. So like, what's with the
So that's just to prevent Daniel asking me question, and I won't have an answer for it.
Alright, I guess so. What's up with the order? L-I-A-T. Like, why
Okay.
is it E-tail?
Liate. It's called liate.
Yeah, why is it like flipped?
Because you will find out the experience that you cannot do it the other way. You can only do it in this particular order. That U has priority is first if you have, the problem is you're going to have some integration. So for example, integration x e to the x. That's the first example on the textbook. It has a composition of a and e to the x. And we don't know that, just give it a try, right? So let's just say if I have x e to the x dx, and I say, can you do di method? Well, can you do the integration by parts first? What is u equal to here? Liate x. Du is what? 1, right?
Yeah.
And dv is what?
dx?
Ex dx. What is v? Ex, right?
Yep.
So now if you have a different order, I will show you. That's a great question. So it's gonna be x e to the x minus integration of e to the x dx. So it'll be x e to the x minus e to the x plus c. Is that okay? Now imagine that if you would do it the other way. So let's say we don't know anything.
Yeah,
Experimental.
U
See
equals
what
E to
happens.
X.
U equal to e to the x. Du equal to what?
Yeah.
E to the x, right? And then this is the wrong way to approach it. Let's show you the wrong way. U equal to x, du is e to the x, and dv is equal to x, and v is equal to what? X squared over 2, right? Now, do you see it? Because you got e to the x squared over 2 minus uv minus v du, right? It makes the problem more worse than before. So the order matters. Priority order matters. So this is not the right way to approach it. And I don't know who come up with the right order. I have no idea. But I think they just experiment which combination. If you experiment which combination, you'll understand that which one it should be better because they work one way and doesn't work with the other way. And I guess they just go in by deductive reasoning, see which ones work first is better than the other. I don't know who come up with the order. I don't even know who come up with the proof of integration by part. It'd be a good thing to look up Wikipedia. But
How come your dv is just x instead of x? Like how come you can just leave the dx alone in that one, but in the other ones you need to? Yeah, that's the thing.
because you gotta you're talking about this part?
Mhm.
Yeah, dv is equal to wait, hold on, x dx, right? Yeah, x dx. No, you're right. So then v is equal to x squared over 2. Yeah.
The second part, like the.
But this is not the right way to approach it, though, right? This is not the right way to approach it. It doesn't work it out
Will your dv always have a dx in it?
because you gotta integrate both sides.
And then in the second part, the uv minus integral v du, do you just always add a dx to the end of that? Like you don't need to take it from anywhere, it's just there.
Because it's VDU, so yeah, actually this one VDU. This is dx. You're right.
I think I have a reason for the order. I feel like it's like it goes in order of the most like significant changes. But I think the first one, ln x, would be like it was like it goes from literally ln just to a fraction. Like arc, we'll say like arc like inverse trig goes from like something like that
And change the fraction.
completely to a fraction.
Completely different. Completely alter their identities.
Yeah, and then
But what's categorized? Which ones? Why is I before L though?
that's okay. That's
So that'll be a question to you. Now, what happened is some lazy mathematician come up with a new way. It's called DI method. DI method is actually easier. So all you gotta do is write down this order. It's a plus minus plus. And so for example, let's say integration of natural log of x. All you gotta do is write down u is natural log of x. This is 1 over x. Is that okay? And I is what? I is gonna be 1, right? Integration of 1 is what? X. So what you're gonna do is you're gonna organize this way. Sorry, organize this way. And if something that is integratable, you stop. Stop here, stop. If it's integratable. If it's not integratable, you keep on going. So for example, now you're gonna write it, it's gonna be x ln of x and minus x over x dx, which is x ln of x minus integration of 1 dx, which is x ln of x minus x plus c. That's it.
Can you do that again?
Yeah, bro. I lose the second time you teach me this.
So think about this order. This is called tablet method. So I don't know if you ever watched this movie called Stand Up and Teach. It's this guy that he's teaching in like very close to borderline of LA. and it's supposed to be the worst school. So he teach people start like how to add fraction at very beginning. He take a apple and he chop to half, and he's like, "This how to fraction." He was the first person bringing knife to school, and he was teach a bunch of gangsters, like most of the gang members. It's a really great movie. He just cut it off. He's like, "There goes a half," and he's like, "Boom," and then everybody's like chilling in the back, and now you see a teacher take a knife and chop the apples, and he convert all those gang members to like the calculus. But the funny thing about the story is that calculus teacher, they got investigated. The student got investigated because they think they cheated. Because that neighborhood, nobody ever, not a single kid ever passed the AP exam. End up the whole classroom passed the AP exam. But according to the movie, they find out they did not cheat. But the true story, they actually cheated.
Okay.
Yeah.
Bro.
The true story is actually they did cheat. They didn't like, but they were still good. Like without cheating, they probably could have got like half pass. But with cheating, they got everybody to pass. But the movie portrayed like a good side of the story. But he did change a lot of people. That guy, he's like a Venezuelan guy. He just go there and he just teach. And he would teach till 9 o'clock at night too. He would teach kids. He would teach those impossible kids, like people deemed to be impossible. Like it's impossible to have one kid pass. That's how bad a school it was because all of them was in either in the crib or blood or whatever getting out there. And yeah. So let's try the DI method of this one. Let's say x e to the x dx. Now, I'm gonna write down d and I. I'm gonna write down plus minus plus. What is d in here? X. Good. And that's derivative of x is gonna be 1, right?
Why is dx?
Huh?
Why is dx? Why wasn't it x dx another one?
No, right now we just use di method
Yeah, but like why?
because a is before e. Liate.
So algebra is just normal x stuff.
Yeah.
Okay, so I think like the first part is U, right?
Yeah.
U goes.
Use d. So
Yeah, U is the first one.
so this one's just gonna go d. Well, okay. So that I is gonna be e to the x.
In the example problem you did earlier, didn't you make it x e to the x as your u?
No, I say this is wrong. I says u is equal to x. Because x is algebra, liate. It's not that hard. Just try it. Try up for a problem. Okay, so it's e to the x, right? So then you say, okay, well, I can take a derivative of e to the x like this. I can say, okay, the way kind of organized is going to be this, right? So it'll be x e to the x minus e to the x
You just load
plus
it
c.
after GA.
Let's do it.
You think I look it's-
I'm literally listening again, and I'm still like,
Just have to do a table. It's called tablet method.
Wait. How do you know which one you multiply by? Like, why do you go down instead of up? Like last
It's
time-
always in this order. It's always this order. If you look like this one is this one, but this is the integrable. You can actually integrate this. If you integrate this, it's gonna be what? E to the x, but it's gonna be minus sign. So minus integration e to the x. It's same thing. The whole thing is you try to get to the 0. But the problem with this one doesn't go to 0. The problem with this one doesn't go to 0. So you're gonna stop right here. If it doesn't go to 0, you stop. You try to integrate it at that moment. So here, try one. Just try one. It's not that bad. X squared.
Wait. I think
Because x squared is like exponentially algebra.
You gotta figure out. If it's integrable, you stop. If it doesn't go to 0 and it's integrable, you stop. If it goes to 0, you keep on going. And you always write down this in this particular order.
okay.
Or you can use the I method. I mean, you can use the integrate by part.
So on
This
the
is gonna be way easier, I promise you, because later on we're gonna get to cycling.
all you just take the integral of it down, or the derivative still.
I is integral, d is derivative.
I is your b.
Yeah.
Jay, what do I do with the 2x?
Now, so you got, wait, what is U though? What is D in this case?
Squared.
No. Wait, hold on a second. D is not x squared.
ln x and then your I is x squared.
Yes.
And then you can.
So write down di and write down plus minus plus. If something is, if it's keep on not going to 0, you can integrate when it's integrable.
So you take the row that you have and then you integrate that whole row
Yeah.
and then that's your answer with whatever.
So what is d in here? ln of x. What's derivative of ln of x? Does it go to 0? No. Okay, so now this one's x squared, right? X cubed over 3, right? So this is the first thing. So it'll be positive ln of x.
Wait, we're integrating. Oh.
X cubed over 3.
What are the lines for?
The line just told you the order. How you're gonna do di method. This is gonna be this way.
So you plug the D column into the I column?
No, just always in this order. Boom, boom. Okay, so it'll be ln of x, x cubed over 3. Now the next one, you're supposed to be, because this doesn't go to 0. Now you look at this, whether this is integrable or not. I hear it's integrable because you got x cubed over 3x, right? So then we're gonna integrate this part minus minus what?
Integral
X cubed over 6.
X cubed over 9.
X squared.
X cubed over 9 plus c. That's it.
Oh, we already did. Oh.
Wait, so then.
Man, I think it's supposed to. I think what people are confused. Is it like this? Is this what it's supposed to be?
Yes.
It's like that.
But I still.
You just do the lines. You never told us what they were for.
So you
Off the line, I was still writing.
Yeah, minus b.
Yeah.
Similar like that. So they just come up with something called table method. So you can actually keep on going till like sometimes you need it 4 or 5 times,
Well, if you take the diagonal.
but you don't want to keep on doing that. So you just do it 4 or 5 times.
Second most left.
Yeah, but
Second most bottom left with the most
but
bottom
then you
right.
take the integral.
And then you multiply those.
You subtract by the integral of the horizontal.
If it's a negative sign.
Oh, yeah.
Oh, I didn't love them.
Now we're gonna go to a little bit harder tomorrow. Now today's not hard. Today is not. We're gonna give you some homework so you can practice. But it's called DI method. It's or in the textbook it's called tabular method. Now I didn't know about this method until I watched that movie because this guy was yelling at this kid. Like he was yelling at this kid. He's like, "How come you cannot do that? How come you cannot take it integrate?" So the kid tried to do integration by parts, right? And he was yelling at this kid who cannot take it integration by parts. He's like, "There is an easier method. You gotta see it. You gotta see it." But they don't see. The kid didn't see it. I said, "I don't get it. I don't get it." And the kid eventually snapped. He's like, "I don't want to do this anymore. Fuck calculus." And he's just like running out the door. He's like, "There's an easy way to do this. You gotta see it." As it talks happening. We're gonna talk about that movie. We're gonna show you that movie scene.
Inspire them.
Huh?
Inspire them.
Yeah. Have you seen the movie Stand Up and Teach? Good movie. It's a guy teaching calculus in Southern California, where it's all a gang member is in.
Do you multiply? Is this one multiplied by this term or
Yeah, so this way. Minus 1 e to that, and that's a
goes
done.
down? It goes
Yeah.
down.
If it down, it just write it down. If it's going this way, just integrate. So it's gonna be the same. So minus integrate for 1 e to the x, it's gonna be negative e to the x. But if we go like this, that's perfect. All right.
No, like the I
Okay.
didn't get the notes or anything.
Okay. What's your question?
If you give us something,